everyone. I think there's an incredible opportunity to be talking to you about what's going to happen when the people in this room that are in their teens are my age in the year 2060, and there are now 9 billion people on the planet. What is the planet going to be like then? What are the things that you're going to have to be doing for food, water, and energy? So some years ago, we started a project to try to address this massive problem, and we called the project Omega. The project is called Omega. It's for coastal cities. Let me tell you how it works. Omega uses protected bays like San Francisco Bay, vast areas which will get even bigger with sea level rise. And most importantly, they already have wastewater treatment plants that currently dump wastewater into the bays. But for Omega, this wastewater is a resource, redirected into floating clear plastic tubes to grow microalgae, the fastest growing plants on the planet and the best producers of oil. The algae grow using nutrients in wastewater, and they use concentrated CO2 from a source like flue gas, which means Omega treats wastewater and captures and controls a major greenhouse gas. The Omega infrastructure is used for solar electricity and concentrated solar thermal. And in some locations, wave-powered generators and wind turbines will also provide power. In addition to energy, the Omega offshore platform supports aquaculture and produces high-quality food without using land and without using water. In fact, saving water is a big deal. It's estimated that by the year 2030, half of all the people in the world will face water shortages. And the current map of water scarcity shows in red that there are already many places in desperate need of clean water. Adapting methods developed for the space station for recycling water, Omega transforms wastewater into clean water using 1/3 the energy required to make clean water from seawater. Omega improves the environment by treating wastewater and capturing CO2. It increases the availability of clean drinking water by recycling wastewater. It supplies food without competing with agriculture. And it provides solar energy as electricity, heat, and biofuels. All things that help move us toward a green economy and a sustainable society. So this is an artist's conception of the Omega system, and this is an engineer's conception of the Omega system, and this is what we did. We spent 4 years and $10.8 million from NASA and the California Energy Commission to prove that we could build a system that works. We solved most of the major technical problems in those 4 years. We built this system that was controlled and that we could understand how we could get food and water and energy. So the Omega project is really to the stage now where we're looking for people around the world to take this on. So we formed the Omega Global Initiative. We've invited what we call Omega ambassadors, people from different parts of the world who have expertise, local expertise, that can teach us how to develop technology there, or we teach them and they are then the engineers and the entrepreneurs and the scientists that need to move it forward. Is that we want to talk to people your age. We want to talk to young people that are going to be the future engineers. And to do that, we've started what we call the International Omega Youth Council, the IO Youth Council. If you think about the planet Earth, the big issues all have to do with water, food, and energy. We're looking for people around the world to take this on. This is going to be one of the most profound things that is going to happen in the history of humanity. If you'd like to help us, go to the website and join us. If you're too busy, you can donate your lunch money or something to help move projects forward. The real challenge had to do with food, water, and energy. Failure is not an option. Thank you.